So we have another sectors and segment question. This one here is asking us to find the shaded region that is here, that is from where these two circles overlap. So this part in here. We are given a little bit of information. We're told the radius from here to here is 8 centimeters. The radius from the center of this circle to the edge is 6 centimeters. And the angle between these two radii is actually 90 degrees. So I can actually use that information to then find out this angle here and this angle here, because what we need to do is find this segment for this circle, this segment for this circle, and then add those two values together. So what I can actually do here, I can actually go, I'm just going to put a little straight line from vertex to vertex. Now what that has actually given me is a right angle triangle, and I can use that right angle triangle to find this angle, to then find this whole angle, to then find this whole angle. So first of all, to find this angle here, I'm going to do tan. So the tan of theta is going to be equal to 6 on 8. So therefore theta is just going to be equal to the inverse tan of 6 on 8. And by doing that, I get the answer of 36.869897. I'm going to leave that to a fair few decimal places just so we don't make an error when we're rounding. Now, in order to find this whole angle here, these two triangles are the same, so I can simply just times this by 2, and by doing that, I end up getting the angle of 73.739995 degrees. So that's this whole angle here. While I'm going to find this angle up this end as well. I'll do this in a different color. So to find this angle here, I'm going to go, again, the tan of theta, this time is equal to, remember, opposite over adjacent, 8 on 6. So therefore theta is going to equal the inverse tan of 8 on 6. And if I do that, I get the answer of 53.13. I can round that one a little bit easier because there's just a lot of smaller numbers after that one. And again, to find this whole angle, I just simply times that by 2, and I end up getting 106.26 degrees. So from here, to find, first of all, this segment, all right, so from my bigger circle, so what I'm going to do, I'm going to label this one here circle A, and this one over here circle B. So first of all, to find the area of segment A, what I need to do, I need to find the area of the whole sector, then subtract the area of the triangle, and that will give me what is left. So remember, for our area of a sector, we have theta on 360 times pi r squared. So I can then jump straight to 73.739995 on 360 times by pi times by 8 squared. From that, I'm then going to subtract the area of the triangle that exists between there, there, and there. The area of that triangle is going to equal to a half of 8 squared times by the sine of 73.739995. So I'm subtracting this answer here from this one here. And if we put that into our calculator, I end up getting an answer of 10.464. That's a little messy. Let me fix that one up. 10.464 centimeters squared. So that's my first bit. I now need to do the second part, and that is going to be the area of segment B. I do the area of segment B. I use this whole angle here, which we worked out to be 106.26 on 360 times by pi times by 6 squared, and then from this value I'm then going to subtract the area of the triangle, which is in this side here, so this triangle here, and with that I'm going to get a half times by 6 squared times by the sine of 106.26. Doing this, I get the answer of 16.10 centimeters squared. So to get my total shaded area, 10.464 plus 16.10, and we get the answer of 26.6 centimeters squared rounded to 1 decimal place.